Okay, so I'm going to go back a couple slides here just to talk about recording techniques because the last few slides all kind of go into this. So just a quick reminder here. Originally, we had silver salt based films, and then now you have more real-time detectors, things that are a semiconductor detector can detect X-ray and then give out a electrical signal for a computer. But we often still have film in use just because sometimes easier you can roll film up and get it into tight areas, things like that. In some cases, it's less expensive too, although you have the expense of processing it, time and materials. And then computed tomography we'll talk about, or most people have heard of CT scans, is taking a bunch of images all together and creating a 3D model. So here's that single dimension, not used super commonly, but it gives you some idea of the amount of radiation that's passing through at different intensities. Most common that we're going to see are two-dimensional films. So here, that composite panel I was talking about and being able to see the honeycomb structure, where the honeycomb structure tapers down to just a straight ply laminate, and then different amounts of epoxy kind of in the areas. We also have enhanced two-dimensional. So this is real time. This is what's happening inside of, the probably one of the most common that you would deal with these is your airport scanners. If you're flying somewhere and you run your bags through the scanners, you see something like this. And so they can actually, they're two-dimensional, but they'll do multiple, they'll actually take multiple X-rays. If you've ever seen one of these in use, where it'll run X-ray through your bag at different intensities, and it allows them to kind of image it at different heights. Now it's different from a CT in that they don't take those and stack them to make a 3D model, but when they're looking through your bag with one of these, they're going to look at those different slices to see what you have all piled on top, and then zip closed so it doesn't explode. Wrong word. So it doesn't pop apart on you, right? I mean, the way my kids pack their bags are like ready to explode without explosives, or they're like sitting on them and trying to zip them, right? But things you can see here. What do you, if you look at this, what kinds of things are you see? What do you think you see? The what? So you got a computer. That one's pretty obvious. What kind of things block more of the X-ray? What materials? Metal. So what do you have that's metal in there? What are these right here? Belt buckles, right? What about this? Anyone tell what that is? Singing in the rain. It's an umbrella. It's a collapsed umbrella. Okay. You can see the buckles or the latches on the suitcase itself, right? And then kind of below it, you can kind of make out like some dress shoes, maybe, right? So that's where getting a scan, turning up the intensity would allow you to image deeper or lower through the part, and wash out some of the higher level stuff and image lower in there. Okay. And then it's enhanced, it's color enhanced. So this uses an electronic detector. What the computer gets is just a bunch of numbers relating to intensity. And then just like in thermography, where we can lay different colors down based on, temperature readings, here it lays down different colors based on radiation intensity, X-ray intensity. I think we've got some headphones here. You can see the cable going to the headphones is dark. Copper is a really good absorber of X-ray. So you can see the copper wires going to things, right? I don't see any like blue wire, red wire, right? Which one should we cut? Okay. CT, computed tomography, very simple form, looks like this. So you have your X-ray source, you have your part. You can see the X-ray source is able to fan in like a beam. So instead of a cone or a straight beam, it tends to fan. And then you can typically move that beam up and down, or you can move the object up and down in order to image slices of it. And there's that detector array. So this is what's happening to you when you go into a CT. You're the part, and you're going to be kind of moved up and down. In the case of a CT, rather than like a medical CT, rather than rotating the person, right? That would be rather uncomfortable and hard to stay still. We rotate the entire detector and X-ray source. So it's got that big ring that you go inside of, right? And CTs and MRIs look very similar, but on the inside they're very different. MRIs are big magnets. We're not talking about that. We're talking about CT, so X-ray. So you know the detector and the X-ray source can swing around, and then you lay there nice and still, but then the table can move in and out, right? And so it can create these 3D scans from all different angles to produce a 3D image that can be used for things. So I do have a video on this. I'll record because some people are sick today. So CT scan of a turbine blade. This is showing one slice. Looks like a typical, looks like just your typical X-ray, but showing things like cooling holes, or gill hole, internal structure. You know, we could see things like cracks would probably be the one most people would think of, right? Looking for cracking. The other thing we can get is over time, particularly in turbine blades, you can get carbon buildup and that kind of thing, and passageways can get clogged as well. And so it's very important to, during the overhaul and cleaning process, to check that all these cooling passages are clear. Otherwise, you'll get areas of heat buildup that will result, you know, they'll heat temper the metal and cause it to crack, burn, distort, or warp. So we want to make sure that that's not going to be the case. Same blade, but looking at it in a 3D CT scan, you can see where this might be helpful in being able to better identify things going on in the internal structure. So rather than just trying to look at this, and if you've got a light spot or a dark spot that you're not really sure what's going on, you can kind of see how it, you know, how it works inside of there, and you can do kind of a fly through and cut the blade apart virtually in order to get a better idea of what's going on. Okay? So